Thank you for joining this lesson. We're going to look at volume and surface area of frustums. The figure below shows a lampshade in the form of a conical frustum. So these are conical frustum with a top radius of 7, a bottom radius of 14, then a sloping height of 20 centimeters. Part 1, the slant height. Okay, calculate the slant height of the original cone, correct to 2 decimal places. Therefore, the original cone can be produced by extrapolating these heights so that they may meet at a certain point. Yeah. So now with this vertex here, we can say this is our, we can call it V. That point, we can call it V. So that now we produce, so that now we may talk of an original slanting height. So there is an original slanting height at this point. Yeah. We can call it capital L. Then a small slanting height, small letter L. Therefore now we want the original slant height, the original slant height. So now we can use similarity and enlargement, whereby we will say, when we take radius of original, divide by radius of the smaller cone which was cut away, since they are lengths, like just the sloping heights, then it will be the same as taking the slanting height of the original divided by the slanting height of the small. And therefore, let me carry out that expression in the space near the diagram. So I'm going to say 14 out of 7 equals to the bigger height, which will be 20 plus small l, divided by the smaller l. Yes, like that. So what I'm going to have here is a 2 after simplification equals to 20 plus L out of L. So I can cross multiply now to have 2L being equal to 20 plus L. We subtract L to this side and you discover L equals to 10. L equals to 10 centimeters. 10 centimeters. Sorry, 20 centimeters, because we are just subtracting. We are not dividing by 2, sorry. Subtract L. L becomes exactly 20. Therefore, the cone which was cut away had a slanting height of 20, which means now the capital L is going to be 20 plus the 20 which was cut, and this gives us exactly 40 centimeters. So 40 centimeters were cut off. 40 centimeters. The next is the height of the lampshade. Height of the lampshade. Height H, that is. So height of the lampshade is going to be given by, it's good we apply now a different concept like Pythagoras theorem, whereby because this height is given, this height is also given, and we know very well that the vertical height here is making a right angle with the bottom radius, and also at this point, then we can now carry out Pythagoras theorem, whereby we will say L squared minus the radius here squared will give us the vertical height when we obtain the square root. Therefore, we can have a, let me work on its space. We can have 40 squared minus 14 squared. Then we obtain the square root. 40 squared minus 14 squared. Then I obtain the square root. This gives me 37.47. This is to 4 significant figures, centimeters. Now with that, we can also get height of the smaller cone which was cut away. Here we will use 20 and 7. So I will say again 20 squared minus 7 squared, the square roots, 20 squared minus 7 squared, then we obtain square roots. This will give us 18.73. Remember, we could have obtained the same by taking a half of this due to similarity and enlargement. Therefore, now with the heights, we can get now the height of the frustum which is remaining by taking 37.47 minus 18.73. So when we take 37.47 and we subtract 18.73, this gives us 18.74. 18.74 centimeters. Therefore, this is the height of the frustum itself. Now we're going to calculate the curved surface area of the lampshade. Curved surface area will be given by curved surface of the original cone minus curved surface of the smaller cone that was cut off. And curved surface is given by pi RL. Therefore, I will subtract pi RL for the smaller cone. So I'll use a pi of 22 out of 7 multiplied by a radius of 14 and a slanting height of 40. Then we subtract 22 out of 7 by a radius of 7 and a slanting height of 18.73. Slanting height of 20, sorry. This is the vertical height, 20. So now let me get these figures. 22 out of 7 multiplied by 14 and by 40. This gives us 1760 minus 22 out of 7 multiplied by 7 multiplied by 20. This gives us 440. So when we subtract 1760, we're getting 1320 square centimeters. Remember, we are just obtaining the curved surface. So that is done. The next, we are told to obtain the volume of the lampshade, correct to 4 significant figures. Volume, again, we're going to use the formula of the volume of a cone, and it's given by a third pi RH. This is for the bigger cone, minus the smaller cone which was cut off, a third pi RH. So now I'm going to substitute a third pi R squared H. Sorry for this. So we need a third of base area, which is circular. So pi R squared. A third of base radius, or a third of base area, which is circular, times height. A third of base area, so it should be squared at that point. So a radius of 14 squared multiplied by a vertical height of 37.47. Then this we subtract a third multiplied by 22 out of 7 multiplied by a radius of 7 squared times a vertical h of 18.73. So now I'm supposed to compute these figures. A third times 22 out of 7 times 14 squared times 37.47, sorry. This gives us 7693.84 minus a third by 22 out of 7 by 7 squared by 18.73, and this is going to give us 961 0.47. So when I subtract now 7693.84 minus 961.47, I'm getting 6,732.37. But remember, the answer should be in 4 significant figures. Therefore, I'm going to have the answer as 6732 cubic centimeters. Cubic centimeters.